There are some questions that combine chi-square and probability in one, and these usually show up in longer papers. So for IB studies, this is in paper 2. So for this question, I'm going to cover the chi-square parts on the slide, and then I'm going to do the probability sections on the other slide. So skip to the parts that you want to do. I would encourage you to have read the question first and attempted the question. So we have the survey where Jorge asked 200 drivers how long they've had the license and if they wear a seatbelt or not. And we have this two-way table. And then he applies a chi-square test at 5% significance level. And the first question is to write the null hypothesis. So usually the beginning of chi-square, try not to mess them up, but they're quite easy to answer. So the null hypothesis is always about the independence. So are they independent? So what are the two things you're conducting? It's basically these two questions. So how long they've had the license and whether they wear seatbelts. And basically you just want to say that these two are independent. So your null hypothesis is, and it could be worded in any way. So I could say the length of, or let's say how long they had the driving license is independent, and this is the keyword, of whether they wear a seatbelt. So you want to see if these two things relate to each other. Now, there are certain words you're not allowed to replace instead of independent, so just be careful. The safest choice is just to go for independent. So that's for part II. So that's for part I. For part II, it's the degree of freedom, which is either you use a calculator for or you can just directly do. Degree of freedom is row -1 and column -1. And the row, be careful, sometimes they add the total here, so you want to make sure that you don't use the total as part of your rows and columns. So you have three categories in your rows. So you have 3 minus 1, and then you have 2 categories in your columns. So you have 2 minus 1, 3 minus 1 is 2, 2 minus 1 is 1, so you have 2 times 1 here, which is 2. So 2 is your degree of freedom. For part 3, you need to find the expected number. So the expected number, you have to use the formula again. The formula for expected value is you take the total of the row that they want, multiply by the total of the column, divided by the table total. The table total is basically adding up all the numbers, which you don't have to do because we know it's 200 drivers. So we have 200 in the denominator. Now, the question wants the expected number of drivers that wear a seatbelt. So we are looking at this column and have had their license for more than 15 years. So had the license for more than 15 years. So we're looking at this row. Basically, what we want to show is that the expected number here is 22. The question is a show that, meaning that you have to arrive to the number 22. Just writing the number 22 doesn't give you any points. So what you have to do is just identify the two things you're looking at and then use the formula. So the total for the row is 30 plus 15, which is 45. So I have a total of 45 for the row. And then the total for the column is me adding up all of this, which is 98. Sometimes this is already done for you. So times 98. Now putting this in the calculator, this will give you 22.05. So you're like, wait, this is not 22. But read the question. It says correct to the nearest whole number. So don't ignore this. Do write 22.05 and then just write that this is 22. So showing your full process is necessary to get to 22. When you have show that questions, make sure that your final answer arrives to the thing you need to show. Now for part 5, we have the chi-square test statistic, and you need to use the calculator for this. So having the calculator already set up, what you're going to do is you're going to have to go and set it up on the matrix. So you're going to go second and then matrix here. And it's going to open the tables for you. This might be empty, it might be full, it doesn't matter. You're going to go to edit and you're going to go to the first one. In the edit, you're going to put the matrix down. So we have 3 rows and 2 columns, and then you put the numbers down. Just make sure that your numbers are all correct. Once you're done, you're going to go to stat, and you're going to go to test because you're doing a chi-square test. So test, and then you go all the way down, and you're going to see that it's, for my calculator, is this C option. So this is the chi-square test. What goes here is your observed value, which is your table from the matrix. And what goes in the expected is any other matrix. If this was empty, then you just go to second and matrix, and you press on the one that you want to input in here. So obviously this is our first one, and then this could be any other matrix, even if it was used up already. It's going to overwrite it. And then you press on calculate, and we have the values. So I have that the chi-square value is 8.12. We have the p-value 0.0172, and the degree of freedom is 2. This is good if you want to check your degree of freedom. So we have the chi-square using the table is using the calculator is 8.12, and that's rounded to 3 significant figures, which is the rounding that most examinations want. For the last part, it asks you, does Jorge accept the null hypothesis? So this is where you have to remember the rule. So the rule is, if your chi-square is bigger than your critical value, you reject your null. Now, we don't have any critical value here, which means we'll have to use the p-value. So the same condition for rejecting for p-value is actually the opposite. Your p-value has to be less than the significance level. So if your p-value is less than significance level, you reject, or if your chi-square is bigger than the critical value, you reject. It's the opposite. So these are, I always write them in the same order. So these are the numbers you get from the calculator. So if you just remember this part, or if you remember the chi-square part and then remember the p-value is opposite, it's easy to remember the rule. So the idea behind this is that if your chi-square value is bigger than the critical value, it means you have enough evidence to reject your null hypothesis. Now, we don't have critical value, we'll use our p-value, which in our case was 0.0172. Your significance level is 8%, but you're going to write it as a decimal, so it's 0.05. And obviously, your significance level is bigger than your p-value, so you reject the null hypothesis. And you have to show your reasoning. So you say you reject the null hypothesis because the p-value is less than the significance level, and show the inequality. So if you reject or accept, you have to write the reason after that, or else you don't get the marks for it. So this was the chi-square section. And then we go to the probability section. So we have one driver is chosen at random from those 200 drivers. And the first part is find the probability that this driver wears a seatbelt. So out of your 200, this is quite a straightforward probability. So out of your 200, you have 200 choices. You need to see what's the probability that he wears a seatbelt. Well, we just need to look at how many people wear seatbelts. And in this case, it's 40. We've already calculated the seatbelt, so that's 98, sorry. So 98 over 200, which simplifies to 49 over 100. So you can write this either unsimplified or as a simplified one. You can write it as a decimal. You can also write it as a percentage. So any format is acceptable. But if they specify percent, then you have to write percent, for example. The second one is the conditional probability. So the driver does not wear a seatbelt, given that the driver has held a license for more than 15 years. So this is your conditional probability. So if I write it down, so does not wear a seatbelt, given that the driver has held a license for more than 15 years. So license is more than 15 years. So writing this is the rule for conditional probability. It's the intersection of this with this divided by the probability of this. So the probability of getting the no seatbelt and getting a license more than having a license more than 15 is this value. So it's 15 out of the 200. So that's the probability of the first one. So it's no seatbelt and license more than 15. And then divided by license over 15. So the license over 15 is basically the sum of all of this row, which is 45. So we have 45 over 200. And this simplifies to 15 over 45, which is 1 over 3. Now, another way to think about this is to replace the probability and just take the number of elements in those sets. So that was one of the ways I explained this. So you replace the p with an n, and you just look at the number of values you have in this intersection, which is 15, and the number of values you have in this category, which is 45, which is what we get. Because you'll always end up dividing by the whole denominator because it's going to be the same denominator. Another way to think about it is that given that he has a driving license more than 15 years, so we are already in this section. So from this section, so the 45 divided by 45, how many of them do not wear seatbelts? It's 15. So it's going to be 15 divided by the whole thing, 45. So the last section is on, again, probability, but it's 2 events. So 2 drivers are chosen at random. Calculate the probability that they both wear seatbelts. So when you have 2 events happening, you need to decide if it's a replacement or not replacement. In this case, it's a no replacement. Meaning that I picked one driver and then I didn't replace it, so I'm picking the other one. So in this case, the denominator is going to be different. So the probability that they both wear seatbelts, so I need the probability of them wearing a seatbelt and then multiply the probability of them wearing a seatbelt again. But the probability of them wearing a seatbelt, we've done that already. It's 49 over 100, or let's take the 98 over 200. So I have 98 over 200. And then we're picking another person that needs to wear a seatbelt, but we've already taken out one person when we did this. So we have one less person here. And because we've already taken out one person, we also have one less person in the total. So this is where you have to be careful with no replacement. The denominator is going to change, and then the numerator depends on whether you need it again. So this is probability of picking a seatbelt and then probability of picking the other one. And it's one less for the numerator and denominator. And you can simplify the answer. So we have $1.99. So we have it as a decimal 0.239. Then for the second part, we have that here where at least one of them wears a seatbelt. And this can be done in 2 different ways. So first, you need to list out all the possibilities. So at least one, meaning that you could either pick the first one to wear a seatbelt and then the other one not seatbelt. So this is the order. Or you pick no seatbelt and then the other one wears a seatbelt. Or you can pick that they both wear seatbelts. So we have all of these options. So what you could do is calculate the probability of each one and then add them together. And then I'm going to do the other quick method. So probability of picking a seatbelt is 98 over 200. And then no seatbelt is basically me adding up this column, which is 102. So this is 102, but I've already picked one person out from those that wear seatbelts. So I have one less person. Notice how I didn't decrease the numerator. The numerator is 102 based on my table, but I did decrease the denominator. And then we do the same thing here. We have 102 over 200 for no seatbelt. And then I still have 98 people with seatbelt, but I have one less person. And then the seatbelt with seatbelt we've done before, so 98, 97 over 200 over 200. And doing the whole calculations and then adding them together. So because you have options, when you have options, you add those options together, and that's going to give you as a decimal 0.741. Now the other choice is to think, well, overall, if I have two options, whether seatbelt or no seatbelt, I will always have either seatbelt, 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 no seatbelt, no seatbelt, and then no seatbelt and no seatbelt. What we've done in the last part was calculate this. What we also could do is calculate this and then take 1 minus this thing to get the others. Remember, they're always complements. So your idea is that I have the probability of no seatbelt happening twice, and then I don't want this to happen. When I don't want this to happen, it means that I want at least one of the options to have a seatbelt. So that's taking the complement. So we could do that. 1 minus not taking a seatbelt is 1 over 2 times 200 times 1 over 1 times 199. And it should give you the same answer, 0.741, when you do the 1 minus.